Hi and welcome to the Beacon Salon Speaker Series. In Season 4, the series stands as the flagship community educational outreach program at Beacon College in Leesburg, Florida. The series brings together brilliant minds and performers from the Sunshine State and around the nation to engage in discourse and debate in the spirit of the French salons of the 18th century. Beacon College is America's first accredited college or university dedicated to educating students who learn differently. Foremost, however, Beacon is a rigorous liberal arts school ranked by U.S. News & World Report as a top college in the southern region. The Salon Speaker Series honors the college's duty as an institution of higher learning to uplift the community, spark engagement, and sow seeds of conversation and discovery. In this installment, we'll explore the fascination with a certain red planet in our solar system. Space, the final frontier. From the moment earliest man lifted his eyes and marveled at the twinkling lights dancing above, mankind has had an enduring fascination with outer space. Now NASA and other organizations want to put humans on Mars in the coming decades. But it's not easy. Just how close are we to meeting these goals? And what are the challenges that stand in the way of making humans a multi-planetary species? In this installment of the Beacon Salon Speaker Series, Brendan Byrne explains why a Mars mission is so difficult and how scientists and engineers are trying to turn science fiction into reality. Brendan Byrne is a reporter and host at WMFE 90.7 FM in Orlando, covering the space beat, which includes everything from rocket launches to the latest scientific discoveries in our universe. His reporting is heard statewide on more than a dozen Florida stations, and he contributes to NPR's national programming. Byrne also hosts WMFE's weekly space radio show, Are We There Yet?, which began as a podcast more than 3 years ago. Byrne is a native Floridian, born and raised in Broward County. He moved to Central Florida in 2005 to attend the University of Central Florida. Please stay with us after his talk for a Zoom Q&A where you space cadets can ask him questions. There is still time to register for the webinar. Visit beaconcollege.edu/salon and navigate to the Speaker Series icon. Now, the Beacon Salon Speaker Series is proud to present Brendan Byrne.
Thank you so much for having me. As was mentioned, my name is Brendan Byrne. I am a reporter and host at WMFE Public Radio in Central Florida and WMFV up your way on 89.5. You also can hear me on NPR. I'm a contributor to their space coverage there. And I also host a podcast called Are We There Yet?, which is also the title of this presentation. As you can see, I'm very creative with my names. But anyways, it's an honor to be here and to speak with you all for this series at Beacon College. I've had the opportunity to work with Daryl in the past, both back in his days at the Orlando Sentinel, and working for Beacon College, and also some of the great faculty there as well. I've interviewed a few of them for my stories and coverage, so it's just an incredible honor to join the ranks of the Beacon folks and kind of educate you about some of the things that I work on and I'm passionate about. And one of those things is space. So we're going to talk about space. We're going to talk about Mars, and we're going to talk a little bit about getting people to live on other planets, particularly Mars, and what other things might be living on planets like Mars. So hopefully we have a really great conversation today. I'm going to be taking some questions at the end of this, so I'll leave some time for that. But we'll go ahead and take a journey. And today's talk is called Are We There Yet? As I said, is the name of my podcast and now radio show, which you can listen to on WMFE and WMFE every Tuesday night at 6:30 p.m. on 90.7 FM or 89.5 WMFV FM. Basically, we started this show back in 2016, so this month it will actually turn 5 years old. And the show had a really simple premise when we started it. We asked ourselves, when it comes to putting humans on Mars, are we there yet? And a lot of the early shows focused on putting humans on Mars. But we quickly learned that there were so many other interesting things happening in space exploration, and especially Mars exploration, that it wasn't fair to just talk about putting humans on Mars. While that is an extremely important topic and something that we will get into today, I really do think it's important to realize that there's a lot of other science that's happening, and there's also a lot of engineering and science and visionary thinking that goes along with putting humans on Mars or another planet, that there's a lot of tie back to other programs and other things that are happening here. So we're going to explore those things today, talking with the long-term goal of what it's going to take to put humans on Mars, but also looking at the things that we're learning along the way when it comes to this. NASA calls humans on Mars the horizon goal. It's always something that's on the horizon, but you never quite get to it. But the voyage and the journey that happens as you're working towards that horizon is what really adds to scientific understanding of both our world, the Martian world, our solar system, and our universe. So we're going to explore all of those things today. I'm going to try to cram it all into 50 minutes. And if I don't get to some of these things, I really do hope that we can talk about it in the Q&A. So I'm going to save some time for us to do that. So before we even jump into anything, we're going to have to meet Mars. Mars is one of our closest celestial neighbors here. It's a small rocky planet, very thin atmosphere, and it's known by its reddish color, and that's from the iron oxide that's on the surface. It's a rocky planet that's been riddled with craters. It has very thin atmosphere, and we're starting to learn that Mars actually was a lot like us in the early days of the solar system, a lot like our planet. And that's what's really fascinating about Mars, right? What happened to make it look like this and not look like the water, atmospheric-rich planet that we live on, Earth, and why does it look like this? And what happened to it, and could that be foreshadowing the future of our own planet? It's also a close celestial body, which means it's a good candidate for us to try to put people on it. As you know, we've put people on the surface of the moon in the Apollo program. The next logical step would be for us to put humans on the surface of Mars. Now, there are quite a few challenges that we have to talk about when it comes to putting humans on the surface of Mars. And so we're going to walk through a few of those challenges, and then I'm going to walk through some of the successes that we've had putting robots on Mars, and we'll talk a lot about that, and then we'll switch back into talking about putting humans on the surface as well. So one of the major challenges with Martian exploration is it's the time it takes to get there, the varying distance that Mars is to Earth, and the harsh environment of deep space travel. So let's first start with the distance. So the moon, let's say, the moon is our closest celestial neighbor that we've been to. 12 Apollo astronauts have stepped foot on it. We've sent, a handful of different scientific experiments to the moon. We plan on going back very soon. The moon is about 240,000 miles away from us. It just takes a few days to get there in a capsule, whether it be the Apollo spacecraft or whatever future spacecraft is coming. So only a few days. But Mars, on the other hand, is extremely far away. At sometimes its closest point, it's only about 300 million miles away from Earth. And that's at its closest point. So we're talking these massive distances away. We're not talking days to get to Mars. You're now talking weeks, not even. We're talking months to get to Mars. Mars and Earth were at their closest points when we launched, or would be at their closest points when we launched a bunch of missions this summer, and they took 7 months to get there. And the reason why is because Earth and Mars have different orbital periods. So that means they don't orbit around the sun at the exact same time. So they're not together all the time. There's not this constant distance, this universal distance between the two. It changes. And it's about once every 2 years they come very close together. And that is when you want to launch your rockets or launch your rovers or launch your humans if they're going to do a Martian exploration mission. It's that's what makes it so difficult. You have to plan your missions around this intricate orbital dance when these two planets are going to be the closest. And you don't launch to Mars, you launch to where Mars will be in 7 months. So there's a lot of math and a lot of planning that goes into it. So if you have a hardware delay or a funding problem, you miss your window. You only have a very, very small amount of time for you to get off of this planet and be able to get to another planet to utilize the least amount of fuel so you can take the most amount of stuff with you. So that's one of the reasons why it's very difficult. While these orbital dynamics are so important to planning these Martian missions. So once every 2 years. This past summer in July, we had 3 missions take advantage of this window. We had the United Arab Emirates sent their first mission to Mars, the Hope Orbiter. The Chinese Space Agency sent a mission to Mars. We don't know too much about that one. They're pretty secretive about that, but we know that there is an orbiter and a lander. And then if anybody's been paying attention to any of the space coverage over the past few days, we know that NASA landed the Perseverance rover on the surface of Mars, and that launched in July as well. So the 7-month journey to get there, all 3 of these missions took advantage of that transfer window. And there will be more missions that will take advantage of this transfer window that happens in some 26 months from July. So that's why it's really important. But that poses a challenge, right? It's a 7-month trip. Communications are delayed. It's about a 20-minute delay between here and Mars if you're trying to send a message to something. So anything that goes there has to be autonomous or be able to fly itself. The Perseverance rover landed itself. Scientists were able to cut down that time from 20 minutes to 7 minutes using some orbiters that were there, but there was still a delay. So if there was a problem, those rovers had to land themselves or troubleshoot themselves. And it's 7 months in deep space. And 7 months in deep space is a very difficult, it's very taxing on electronics and hardware, and if we're talking about humans, on the human body. We are protected from solar radiation from a phenomenon called the Van Allen belts that kind of blow away any of this dangerous solar wind and solar radiation from hitting us. But when you're in deep space, you don't have that. And Mars actually does not have that same sort of defense mechanism. So not only are you dealing with dangerous radiation, which we're really not sure what long-term deep space radiation will do to the human body. We know it has the ability to kind of scramble computer systems and hardware on space vehicles, but we're not sure what it would do on the human body. So if you're talking about a 7-month journey through deep space with radiation that we're not really sure what it will do to the human body, well that's really dangerous. So those are some of the challenges of a human spaceflight mission to the Red Planet. We've got a distance of some 300 million miles, traversed through deep space, being pelted with solar radiation, and you also have 1 in 2 years, or a one-time opportunity every 2 years to pull off this mission. And then, mind you, return missions would have to fall into that same window as well. So right now, human missions are extremely difficult and extremely challenging. And we still are not sure that it will happen anytime soon. The earliest, some experts say that we'll be able to send humans to Mars is in the 2030s and the mid to late 2030s. That's a long time to have to wait for something like this, but there's so much that has to go into planning one of these missions. But missions to Mars have been a success. Mind you, they're not human missions, but they have been successful. There's a fleet of different rovers and orbiters and probes that have been sent to the red planet, dozens or handfuls at least that have gone there. And there have been from all sorts of different countries and from countries that have gone there. And there have been quite a few successes and quite a few failures. So if you take a look at this chart here, you can see this was written before Perseverance and the Tianwen-1 landed, but this was put up by a great organization called the Planetary Society. If you don't follow the Planetary Society, definitely give them a follow. They are at planetary.org. Their CEO is Bill Nye, the science guy, and they do some really great public outreach and some really great government lobbying for space exploration. So they put together this incredible map of some of the successes, failures, and the future missions to the red planet. You can see that there's quite a bit that have happened, and quite a few successes, especially the success of Perseverance last week. So before we kind of get too deep into talking about some of the human aspects of a mission, I'd really like to dig into some of these robotic missions that are paving the way for our human explorers to go to the red planet. And I think I'm not going to cover all of them because that would take up all of my time here. But we're going to highlight some of the more interesting ones that happened recently. And I want to start with the Mars exploration rovers. Now these are known as the MERs, Mars exploration rovers, but you will probably recognize their names, Spirit and Opportunity. So these were a dual set of rovers that were sent to the red planet in 2004 by NASA. To kind of have some kind of built-in redundancy. Putting a rover on Mars is very difficult. There had been quite a few failures before this, so why not send two and increase your chances of having a successful mission? So that's what NASA ended up doing. Spirit went from 2004 till about 2011. Opportunity ended up ending its mission in 2018. Now, these far exceeded that, I think, to some 90 days that NASA had expected them to live and work on the red planet. But these were really interesting rovers. One thing that was interesting about them is they're smaller rovers, so they were able to use these solar panels to power them instead of using some of the more dangerous and complex radiothermal nuclear generators that we'll talk about in some of the future rovers that are out there. So they used these solar panels, so they were a lot lighter, a lot less dangerous, a lot less complex, but that also led to their demise. They would get Martian dust would cover them up, or in Spirit's case, Spirit got stuck in a sand dune and really couldn't go too far. But they did some really, really interesting things for space exploration and for Martian exploration. One is they confirmed the existence of previous liquid water on the planet. Now, why is this important? Well, scientists and astrobiologists believe that for there to be life, it is most likely, because the life that we know here on Earth would need liquid water. So that's what we know about life here. That is what we look for on other worlds when we're searching for either current signs of life or evidence of previous life on planets. Scientists have a pretty good idea, or have a really good hypothesis, or think that there was prehistoric life on Mars. Mars was once, thanks to Spirit and Opportunity and some other geological surveys, we know that Mars was once filled with water and lakes and had an atmosphere and had all of these conditions that are quite similar to the conditions here on Earth that sustain life here. So scientists just needed to prove that some of those conditions were met in the past, and that's what Spirit and Opportunity did. They also studied the first kind of in-depth look at the geology of Mars and kind of look at these rocks and pebbles and dirt, they call it regolith, on the red planet, and help get a really good understanding of what the composition of the planet was. No longer were they taking looks at the planet from above and taking pictures and using aerial or orbital ways to observe what was on the surface. They were actually looking and seeing close up what these materials were made of. So those were kind of the two really big scientific things that Spirit and Opportunity gave to us about Mars, and really opened up this golden age of Martian understanding. But I think from a perspective of someone who does communication and public outreach, I think one of the most important things that Spirit and Opportunity did is it gave the public the first incredible looks at the red planet. Just take a look at this panorama. This is incredible. This is an image from another world. And when this image was first released, it really put people on Mars. Now, not literally, but it put you in the mindset of being on Mars. And having this kind of outreach tool to be able to see through the eyes of a robotic explorer into another world was just incredible for drumming up public support for Martian exploration. And it really just opens up so many questions. Even if you're not a scientist, you look at an image like this and you want to go there. You want to know what happened to it. You want to know what those rocks feel like. You want to know what it smells like. You want to know what it would be like to be on the surface of another planet. And we were able to do that with Spirit and Opportunity. And I think that is kind of one of the misunderstood things that Spirit and Opportunity did for science and understanding and public support for Martian exploration is deliver just these incredible images of the surface. Now, since then, we've had even more incredible images delivered to us. But this was kind of that first look of another world. We're putting ourselves, in the shoes of this alien explorer on another planet and seeing this beautiful desolation, this incredible, rust-colored, pebbled world that really, for the longest time, was just a red blip in the night sky. And I think that is the most beautiful and poetic things about science, is being able to see these incredible images from another world. So I hate to harp on that, but I think that was kind of one of the most consequential things that came from these, from a public opinion standpoint. Mind you, the science that came from these were just incredible. But for folks like me and you, this was really neat. This picture speaks volumes and really does inspire people to want to reach out and go to Mars. We had another really great a scientific mission called the NASA's Mars Reconnaissance Orbiter. It's called the MRO. And if you've been following any of the recent Perseverance coverage, you'll know that the MRO helped that vehicle land. It helped relay information back and actually caught some really cool images of the Perseverance landing on Mars. Now, the Mars Reconnaissance Orbiter, it went into orbit in 2016. Its main goal was to take a top-down look at geology and weather. And one of the main things it looked at was, is Earth's geology unique? We wanted to compare the geology on Mars and the geology on planet Earth and see, are we a diamond in the rough? Are we a 1 in a billion entity in our solar system or in our universe? Is Earth unique, or are features found on Earth also found elsewhere? And are they found right in our backyard, our closest celestial neighbor? And it also did a study of how much ancient water was actually on Mars. So we have the Mars exploration rovers were able to confirm the presence of previous liquid water. Now the Mars Reconnaissance orbiter was there to see, just how much of that planet was covered with water, because that is what we're going to use to determine if it could have ancient life, if it could have ever sustained life in its history, because we know that we need liquid water to foster life. So we need to know how much there actually was on the planet. So the Mars Reconnaissance Orbiter is still up there, still doing great science, and as we'll talk in a little bit, it also helped Perseverance land and caught some pretty incredible images of it landing. The next one is NASA's Curiosity rover. Now this is a fascinating little machine that is still doing some great science on the surface. It landed in 2012, and its goal was to see just could Mars support life, and it wanted to take some long-term weather and radiation observations. So it did a lot of really, really interesting geological work, actually drilling samples and sucking it into a lab on board on that deck of it and processing these samples and looking to see what was in them, and then taking long-term weather and radiation observation. Now, as you know from us talking about the difficulties of landing on Mars or sending humans to Mars, we know that radiation is a really big deal. So being able to see what kind of radiation is being absorbed on Mars is very important for future human explorers. As I mentioned, our planet here, we're protected from that solar radiation, but Mars is not. So we would have to plan how much radiation potential astronauts would be exposed to, and how can we mitigate that radiation exposure. So Curiosity is doing very, very good work in trying to preview the living conditions for future Martian rovers, but also future Martian astronauts. And that rover is still kicking and still doing some great science down there on the surface. Now, I kind of alluded to this before. This is the Mars Perseverance rover. I think back then when this photo was taken, it was only named Mars 2020. But this is the newest rover, and I love this image of Mars Perseverance because you can just see how friggin' big this thing is. I mean, this is like a VW bug that is now rolling around the surface of Mars. Well, it's not rolling yet. It's on the surface of Mars that will eventually be rolling around. You can kind of see at the back right of that image, you can see some technicians and engineers there in some bunny suits, and it really gives you a sense of scale as to, how massive and big this thing is that's out there exploring Mars. And we'll talk a little bit about what it's doing in a little bit, but I want to talk about a thing called EDL. This is Entry, Descent, and Landing. And we talk about it in the context of rovers because it's a very difficult part of a robotic mission. But it's also going to be a challenge for future human missions and spacecraft. So the Martian atmosphere is very thin, and usually these things are coming in very fast, some 15,000 kilometers an hour, after they've been zooming through the solar system for 7 months. You have to slow down because you cannot crash into that. But the Martian atmosphere is really difficult because it's not quite thin enough to slow you down using parachutes. So you have to get kind of creative. So NASA came up with this plan. So basically, it will come through the atmosphere. The atmosphere will slow it down for just a little bit, and then a supersonic parachute will deploy. Now, as I said, that parachute is not going to be enough to slow it down. But also, we can't drive it here on Earth because there's a delay of minutes. So you can't grab a joystick and drive it around. So it used a radar system to help find a landing site in a place called Jezero Crater. And once it locked onto that landing site, a sky crane is what it's called, actually came out of the spacecraft. And there's a crane and a little rover, and the rover is hanging underneath it. Now this crane is still flying pretty fast because it can't slow down all the way with those parachutes. So it's got a bunch of rockets on the bottom of it. And those rockets slow it down just enough so that it hovers, and then using cables, the rover is dropped on the surface. It's absolutely incredible. That's how Curiosity landed. It sounds absolutely wild as from an engineering standpoint, as this is the way that you're going to land on another world. But it worked for Curiosity. But we never knew what it looked like. As much as engineers wanted to, they never had cameras on it. Well, for this particular mission, they did. They had multiple cameras on the vehicle. They have a camera that's looking up at the parachute and a camera that's looking down from the rover. And they are just incredible images. If you haven't seen them yet, I'm going to show them to you just because they are really worth watching again. So I'm going to kick it over to 3 minutes of the harrowing EDL, the entry, descent, and landing of Mars Perseverance rover.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Applicate indicates chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Gear and safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance Safely on the surface of Mars, ready to begin seeking the signs of past life.
That's just such an incredible video. Never before seen have scientists and engineers been able to see that technology in action. It doesn't look real. It looks like science fiction, but I can assure you that is absolutely real and absolutely incredible and just amazing. So now that Perseverance is on the surface, and this image right here is one of the first color images that it sent back. Now it's using currently some of its lower powered engineering and navigation cameras. And over the next days and weeks, scientists will fire up the much higher resolution. This is an incredible image to see in this incredible place on Mars called Jezero Crater. Now, the Perseverance rover, it's building on what we've learned from those other rovers that we talked about, from Spirit and Opportunity and from Curiosity, and also from the Mars Reconnaissance Orbiter. Now that scientists know that there is liquid water, and there was an abundance of liquid water, they've actually identified, using the Mars Reconnaissance Orbiter, this crater, this Jezero crater. And it once was home to an ancient lake and a river delta. So it's a really good place to look for evidence of past life, right? You're looking at where all of this water has flowed into this delta, so it builds up all this sediment. And this rover is going to go and look for evidence of carbon-based organisms that were on the surface at some point, or could have possibly been on the surface at some point in its history. That's fascinating. That's incredible. It's going to use a suite of instruments on top, including a microphone and a laser, and it's going to shoot these rocks and all this stuff. But another really interesting thing that's going to do is it's going to collect samples. If scientists find it's found a sample that is extremely fascinating or has some of these signs of life, it will collect it in a tube and it will put it onto a cache, and then we'll drop it up on the surface. And in the next decade, in the 2030s, NASA and the European Space Agency are going to go back, and they're going to pick up these little pockets of dirt and rock samples that Perseverance picked out and prepared. And they're going to fire them back up into Martian orbit and then send them back to Earth. So we'll actually be able to get our hands on these samples. So no longer are they going to be, these samples on another world that we can't get our hands on and test with equipment down here on Earth. But we're going to be able to actually hold them here on Earth. And you might be asking, why are we talking so much about these robotic rovers? This conversation was billed as we're talking about putting people on Mars, right? Well, the Perseverance rover is doing some really important work when it comes to human exploration, because while understanding the geology is interesting to the geologists, we want to get to Mars and we want to put our own astronauts and our own humans there. So one of the things that's on the Perseverance rover is this instrument called MOXIE. And basically what this is, the atmosphere of Mars is mostly carbon dioxide. It's not something you would want to breathe in, as we know down here on Earth. So what MOXIE will do is it actually scrubs the air and turns it into pure oxygen. Now that's going to be extremely important for humans that are going to be living on Mars, because there's very little oxygen, and we all know that we need oxygen to live. To be able to have a machine that will be able to utilize the Martian atmosphere will be very, very helpful. So really, that's really exciting. There's also some material on board that will possibly be used for future Martian spacesuits. So we're going to see how it does in that harsh Martian atmosphere and with all that radiation. What materials would be best to use for a spacesuit. So there's all these things that are there. So yeah, robots are there, but really, what's super exciting is the prospect of humans going to the surface of Mars. And so that's what we're going to spend the last part of this conversation hashing out is, why is this so difficult, and how are we going to do it? So we already talked about some of the issues for the rovers, right? We talked about, the distance away from Earth, the time it takes to get there, and the precise times that you need to launch to get there efficiently with the least amount of fuel, so you can take the most amount of stuff. We also talked about the exposure to deep space radiation, and also radiation on the surface. But when you talk about humans now we have a whole nother bout of challenges to deal with, right? So let's first talk about the temperature. So as you can see here, Earth's temperature fluctuates quite a bit, right? It gets up to 136 degrees. I think that was recorded here in Florida in a summer, and can go all the way down to negative 126 degrees. That's very, very cold and very, very hot. We're average about 57 degrees Fahrenheit here on Earth. But when you look at Mars, because of that thin atmosphere, it cannot hold in a lot of heat from the sun, or because it is farther away from the sun. You're looking at temperature fluctuations from 86 degrees as the high. We would love that here in Florida, right? If you told you it would only get to 86 degrees here, that'd be wonderful. But it can go all the way down to negative 284 degrees. That's freezing. That's way past freezing. If you can see that post where water freezes, and it's got the average temperature of negative 81 degrees Fahrenheit. I would deal with an average temperature of positive 81 degrees. We're dealing with an average of negative 81 degrees. And part of that is from the atmosphere, right? So this is the atmospheric composition of Earth is in blue here. It's mostly, pretty safe nitrogen and life-giving oxygen, 21%. And there's some other things in ours. But if you look at Mars, you got some really dangerous stuff. Your carbon dioxide, argon, all these other different chemical compositions in the atmosphere. You can't breathe it. You'd either have to bring your own life support for like water, food, oxygen, or you'd have to figure out a way to use it. And there is nothing on Mars. We have seen those pictures that we got back from Spirit and Opportunity and the ones that have come back from Curiosity and Perseverance. There is nothing there. There's not a 7-Eleven. There's not a Publix. There's not even a darn lake for you to just grab drinking water from. So you have to bring all of this material with you. And to do that, a human mission to Mars, it would take a massive amount of stuff that you would need to survive. If anyone saw the movie The Martian with Matt Damon, it was based on a book by Andy Weir, they used a system called the Hermes. And this is an image from the movie. This is not real hardware, but you can see just how big this is because you have to get all of this stuff there. And the more stuff you need to bring means the more fuel you need to get it there, to get it out of the gravity well of Earth and to stop it once you're flying through space, to slow down enough to land on Mars. You've got to have everything with you. You've got to have your water, your food, your oxygen, a way to deal with your waste. All of these things. You need ways to communicate. You need ways to build habitats, which will likely be underground for our first Martian explorers. And that's going to take a lot of stuff. And you need a lot of stuff because you're going to be there for an extended period of time. It takes 7 months to get there. So you're going to need the stuff while you're getting there. You'll need stuff while you're there. And then you got to wait for those orbits to match back up again for you to come back home. So you have to keep everything with you. It sounds like an impossible task, but NASA and other agencies, including private organizations like SpaceX, are working to do that. And for us to do that successfully, we're not just going to go to Mars first. We're actually going to start a little closer to home, at the moon. As I mentioned at the start of this conversation, Mars is some 300 million miles away at its closest point. The moon is a constant 240,000. Yeah, that's far. But when you think about it in the grand scheme of things, that's pretty close by. So NASA has devised a new program called Artemis. And the Artemis program, Artemis in Greek mythology was the twin sister of Apollo. Apollo was NASA's first program to the moon. Now we have Artemis, which will return humans again. And if you can see in that image from NASA, there's Mars poking out right behind it. Mars is on the horizon. There's that horizon goal. And the plan is to launch a series of missions from the Kennedy Space Center. Artemis 1 will have no crew. Artemis 2 will have a crew that will orbit the moon and then come back home. And then Artemis 3 will land humans on the surface of Mars. And from there, we hope to learn about all the things that we're going to do later on. So we're going to set up a base camp. There's going to be a small space station in the orbit of the moon to help facilitate these missions back and forth. So this is the Artemis plan. It's been explained to me like, if you're going to go camping for the first time, you don't hike the Appalachian Trail. You test out your equipment in your backyard or at a KOA campsite first before you go all the way out there, because you're close to home if there's anything bad happens. So right now we're developing some of that hardware to get us to the moon and then use that hardware to get humans to Mars. So one of the things that's being it's actually finalized here at the Kennedy Space Center is the Orion space capsule. So this will launch on one of NASA's new rockets called SLS, and it will help carry humans to that moon space station and then back down to the surface. So what we learned from developing this capsule, this deep space capsule, that's going to take multiple trips to the moon and back, is going to help us develop what we will need to go to Mars. Now, it might be this capsule will help get us to Mars. It might be another spacecraft that NASA comes up with. But the plan now is to utilize this for deep space exploration, the first deep space vehicle since the Apollo Command Module. And that's coming together at the Kennedy Space Center. NASA's still hoping for an uncrewed launch of this on a trip around the moon by the end of this year. We're also looking at the human factors, or NASA is looking at the human factors of a deep space mission. And one of the things that I find the most fascinating about a deep space mission and space exploration in general is the toilet. It's an often underlooked thing when you talk about space exploration, but you have to do something with your poo. You have to do something with the urine that you create while you're on these missions. The International Space Station just got this brand new toilet recently. It launched from Kennedy Space Center, I believe, late last year. It's the Universal Waste Management System. It's a new toilet. It's supposed to be more efficient. And it's also supposed to be, it was designed to better accommodate female astronauts, which is something that's very important for NASA, is to make sure that there's gender equality in the astronaut corps and through the hardware that they would use for exploration. So there's a new design to make it easier for women to use, so they can be used by men and women. Because basically, if you can't, you can recycle urine, and that's what the International Space Station does. Any liquid waste is recycled and turned into drinking water. But solid waste is usually packed up and burnt up in the atmosphere. But you can't really do that on a deep space mission, right? You don't have these cargo vehicles coming to visit you and take away your trash. You've got your own trash. So you need to make sure that you can safely store fecal matter and solid waste, because it's very dangerous. There's a reason your body is expelling it. And if you're in closed quarters like that, if something bad happens, it's going to be not only stinky and gross, but it could be very detrimental to your health. So that's why the space toilet is probably one of the most important pieces of human space flight hardware. So this toilet is up on the International Space Station. Another version of this toilet, a duplicate, will be placed on the Orion capsule for those astronauts to use to test out. And the lessons that NASA learns on this will be used for deep space missions to Mars and beyond. Now speaking about waste, what about trash? You might accumulate a lot of trash while you're in space. There's that solid waste that I talked about, but there's also, wrappings from equipment or from foodstuffs, and all of that accumulates. So what are you going to do with it? Well, there's a team at the NASA Kennedy Space Center that's developing a system called Oscar. It's the trash to gas system. And basically what this does is you can place all of your trash into this system. It burns it up at this particular temperature, and some chemicals are expelled that you can use a process called a Sabatier reaction, and you're able to take that and turn it into hydrogen and oxygen and water. So you can drink the water, or you can use the hydrogen as fuel and the oxygen to breathe or as an oxidizer. So you're making your own fuel from trash. It's been developed at the Kennedy Space Center. It's been going through a lot of testing, and hopefully it will fly in space just to make sure that this will work. But this would be game-changing for deep space exploration. If you're not only dealing with your trash and your waste during your trip to Mars, but you're also turning into vital resources, that is extremely, extremely helpful to what you're doing. And that brings me to my next point, is that it takes so much stuff to survive on Mars. Wouldn't it be easier if you can just make it when you get there? And that is something that NASA engineers and also other space visionaries are trying to tackle. It's something called in situ resource utilization, making what you have when you get there. So NASA has some plans to, as we talked about with MOXIE, to scrub the carbon dioxide out of the air and turn it into vital oxygen that you can use. There are also programs, like we just talked about, Oscar and the Trash to Gas, to turn in waste into vital resources like rocket fuel or water or oxygen. Or also turn in the Martian regolith, that's what we call dirt and soil, into building materials. And so in situ resource utilization is something that's going to be very, very important to sending astronauts to the red planet or having a long-term base camp there. And those are a lot of the things that we're going to utilize in the Artemis program and try out on the moon first before applying them to deep space missions to Mars. Now, that's NASA's plan. Elon Musk is the founder and lead engineer of SpaceX. And that company was founded in the early 2000s with the goal of colonizing Mars, putting humans on Mars as a plan B for what we're doing to this planet. Eventually, humans will need another place to go, and that's what Elon Musk wants to do. He's building his company by flying the Falcon 9 rocket, putting commercial and military and civilian science payloads into space. He's building a Starlink internet satellite company. But his ultimate goal is to put humans on Mars. And while that sounded kind of like a pipe dream at this, the early 2000s and even in the mid-2010s, now a lot of that stuff is coming to reality. And his plan is to use a system called Starship. And this is a massive space vehicle that could take hundreds of people at a time with tons and tons and tons of cargo to the surface of Mars. And it looks kind of like a water tower that launches straight up, and then as it comes into the planet, it comes in like a belly flop, and then it lands vertically, much like its Falcon 9 boosters do. And this sounds like science fiction, but SpaceX has actually done quite a good job at building prototypes for this. And one of the prototypes, I'm going to show you a video here. This was the launch a few weeks ago of what's called serial number 9 of the Starship. And while it didn't land successfully at the pad, as you'll see in this video, it did accomplish a lot of goals, and that was to launch from the pad, control this belly flop maneuver that would be needed to enter the Martian atmosphere and slow down, and then propulsively land vertically. So let's go ahead and take a look at this video and just watch how incredible this is.
Stage Bravo's go for flight.
that video is really cool. You know, SpaceX is still years, if not decades, away from putting humans on Mars, and you know, NASA is the same. So I don't want to leave this conversation with you thinking, well, oh, nothing's going to happen. You know, I want to give you something to look forward to. So there are two things that I think are going to be really exciting to watch. One is the development of Starship, as we saw. SpaceX continues to build these vehicles in Boca Chica, Texas, and launching them on these test flights that just keep going higher and faster each and every time, and it's just incredible to watch. Another thing to watch will be NASA's Artemis missions, which could launch as early as October of this year. Although that will likely be delayed into next year. But those are two things that are happening in the now that are extremely exciting. And I think that's something that I can leave you all with to look forward to, you know, moving throughout this decade and into the next in human space exploration. And I think another really important thing to look forward to is the Mars generation of astronauts. They're probably already alive and probably already studying science and engineering or some sort of STEM field. The people that will step foot on Mars are with us today. And I think that is one of the coolest things to think about, is that our kids or, you know, our nieces or nephews are going to be the ones that will suit up in that Martian spacesuit and plant their boots on the red planet for the first time. They're already around. And I think that is the most compelling thing about human exploration, is that we are so close to doing great things. And it is just super, super exciting to follow along that story and see these things take shape and take development and watch humanity take that next giant leap into places that we've never been before. So that does it for my presentation. I would urge you all to take a listen to my podcast and radio show, Are We There Yet? These are the kind of conversations we have every week. You can either download it as a podcast wherever you get your podcasts, on NPR One, iTunes, Spotify, or you can listen to it on the terrestrial radio. It's Tuesday nights at 6:30 p.m. on 90.7 WMFE in the Central Florida area and 89.5 WMFV up in North Central Florida, the villages in Ocala. And you can also hear my reporting on NPR from time to time. Follow me on Twitter at SpaceBrendan, or if you have any questions or want to get in touch with me, my email is there for you, bburn@wmfe.org. Before we kick it to Q&As and send it back to the MC of the event here, I do just want to say thank you so much for tuning in. Thank you for the opportunity to tell this story. It is a privilege for me to be able to do this as a job every single day. And I do not take that for granted, so I love talking about this stuff. So I'm more than happy to talk anytime, and I do hope you tune into to our coverage. So thank you very much, and I look forward to fielding some of your questions.
Thanks, Brendan, for that out-of-this-world presentation. You'll get your chance in a few minutes to explore space further in our Zoom Q&A. First, a quick segment regarding why Beacon College might best suit the needs of someone you love with learning differences. For more information about Beacon College, visit our website at beaconcollege.edu. Meanwhile, it isn't too late to register to participate in our Zoom Q&A. surf to beaconcollege.edu/salon and click on the Brendan Byrne event to locate the registration link. So, it's about that time. Let's welcome Brendan Byrne. Welcome aboard, Brendan.
Thanks for having me.
Well, it's a pleasure. I love the presentation, and I think we already have questions queued up for you, so let's blast off. What's our first question tonight, Ron?
Do you think there are parallel universes, and also does time really go by fast when you're traveling to another planet?
That is very good. Well, I do answer for sure. Are there parallel universes? Maybe. Does time go by differently when you travel? Probably. We haven't done any of that yet, so I haven't been fortunate enough to report on that. But we have a wonderful portion of our program on Are We There Yet, where we have a cosmologist who answers all sorts of questions of theories of relativity. So I will put that to him, but unfortunately, I can't answer that one right now.
And I should remind the viewers out there that if you have additional questions for Brendan, please type your question into the Q&A portion of the Zoom webinar. Ron, is there a second question tonight?
There is. Someone would like to know, is time travel possible?
Ooh, that's another relativity question. I don't know. I don't know the answer to that. I would like to think so. I don't know. I know that there's a few things that I've regretted in my past that I would like to fix. But I don't know if time travel is possible. That is kind of out of the scope of what I cover. But again, those are some of the big questions that scientists are asking when you talk about faster than light travel. Or trying to go to places outside of our solar system, like to these new exoplanets we're discovering around other stars. We are going to have to travel faster than light if we're going to make it there, and bending space and time are something that you'll have to think about when you do that. So it's very well possible that time travel will happen. I don't think it's happened now, but we'll leave it at that.
Another person has asked, if you had the opportunity to travel to Mars, would you go?
I wouldn't be the first person to travel. I remember when I first took over this beat back in 2015, my wife had a conversation with me, and I thought it was kind of silly at first, where she said, well, yeah, if you're going to cover space, if you get the opportunity to ever go to space, you can't. It's too dangerous. And I kind of laughed it off and said, well, that will never happen. I'll never get the chance to go to space. But that is actually a lot more possible than I thought even just 5 years ago or 6 years ago when I took over this beat. SpaceX is going to be flying private astronauts both to the International Space Station and into orbit, possibly as soon as the end of this year, if not early next year. So those are the kind of the questions that I have to ask myself: is if I have an opportunity to report from space, will I do it? And I think yes, I would, but I probably wouldn't be the first journalist to go. I'll let someone else take that chance before me, Daryl.
I don't blame you a bit. Don't blame you a bit. Well, let me ask you some questions too. And once again, if you guys out there have additional questions, please feel free to type your question into the Q&A portion of our Zoom webinar this evening. With China's Tianwen-1, I hope I said that right, the United Arab Emirates Hope probe and NASA's Perseverance rover on Earth's neighboring planet, is it fair to say that we find ourselves in a space race comparable to the energy of the late 50s and the 60s?
I really do think we are, Daryl, and that's a really good question. I think there are a lot of companies that are trying to get to places like Mars and the Moon. Right now, unlike the space race of the Apollo days of the 1960s, there is a lot more international collaboration. So One prime example is the International Space Station. There's multiple companies that run that. We have a relationship with Russia and Japan and the European Space Agency to run the International Space Station. And quite frankly, next month, NASA is launching a Japanese astronaut and a French astronaut from the ESA on SpaceX's Crew Dragon capsule from Kennedy Space Center. So you can see that international collaboration that's happening. But a lot of the politicians, the people that are responsible for funding these programs, they do see China as a threat to a national superiority when it comes to space exploration. And China's rapid development of what they're doing, they're sending their taikonauts into space, and they want to build a space station, and they've got this ambitious rover at Mars. It hasn't landed yet, but it's in the orbit of Mars. We see that as a threat here. So if we want to maintain our space superiority, we have to beat China. And I think that's kind of propelling our space policy moving forward into this decade and probably into the 2030s. There is a new space race brewing, and it's us against China at this point.
Let me segue into looking at the civilian stakes. Back in 2014, when I was still in my newspaper columnist days, I wrote about Mars One, and you probably remember Mars One, Brendan, which was a one-way trip project to colonize Mars with 100 ordinary folks from around the world. That company went bankrupt in 2019 and now has been dissolved, leaving these would-be Martians marooned on the big blue marble that we're living on now. But I'm wondering, have there been any other initiatives like this outside of NASA to plant humans on Mars or other extraterrestrial bodies?
I think the big player right now is SpaceX. SpaceX was started, as I mentioned, in 2002 as they wanted to colonize Mars. That was the business plan, and everything that SpaceX does is to fund that mission. That water tower that we saw kind of belly flop down and crash at the launch pad, that's designed to hold 100 civilians to take them to either the moon or the red planet. So I think if anyone is going to be bringing private people into space to places like the moon or to Mars, it's going to be SpaceX. What are they going to do when they get there? That's a completely different question. What are the ethics behind that? We're not even sure if there's current life or signs of life on Mars. What will it do if we start living on that planet? But I think if there's going to be any company that's going to do it, it's going to be SpaceX. And unlike Mars One, they do have the funds to pull this off. They're bringing in the money to make this happen from their commercial launches that anybody who lives in Central Florida can see that they're launching almost every week. It's not just a NASA mission. That's a commercial mission for millions and millions of dollars they're getting. They're putting a constellation of internet satellites above us that are going to provide global broadband access, which is going to be a huge cash cow for this company. So I think if anybody is going to put people on another planet, whether it be Mars or the moon, or even Elon Musk is thinking even beyond Mars, it's going to be SpaceX.
I think we have another audience question.
This one comes in from Facebook. What does Brandon think the government is going to unveil or reveal about UFOs?
That's always an interesting question. I know that there has been some legislation or executive orders to release what we know about UFOs. I think the more interesting thing is what we're doing to explore outside of our planet. The UFOs, there's usually some sort of explanation for what they are. But I think the more interesting thing is, what is the U.S. government going to reveal about their ambitions to explore outside our planet? A lot of people think UFOs mean that there are aliens coming to visit us, but I think really what our government needs to do is invest in a lot more money to survey our skies and see if there are, other alien civilizations outside of our planet and our solar system. So I think that's the more important question to ask. Not what is our government hiding from us, but it's what is our government willing to do to explore what is out there. So I think that's more important.
All right. In November, NASA's Planetary Science Division's Mars Architecture Strategy Working Group delivered a final report to NASA titled A Comprehensive Program for Future Mars Exploration that lays out an agenda for investigating Mars using a wide range of approaches meant to kickstart a higher cadence of scientific discovery at a sustainable cost. What has been the response to what the group has outlined in this report, Brendan?
So they're actually having discussions now, and what happens with our future Mars exploration actually starts with what is there now. So there's the Perseverance rover, and I mentioned a bit in my talk about the sample caching. So basically, the Perseverance rover is out there to look for ancient signs of life. Scientists are pretty sure that not only was Mars covered with water, but it had a very good chance of harboring actual life, whether it be very, very tiny microbial life or something larger, a larger organism. But they think that the evidence of that is locked in the fossil record of Mars. And that's what Perseverance is out there to do. But more important, Perseverance is out there to collect samples of the Martian soil and rocks and put them into these little tubes and leave them laying all on the Martian surface. And through this partnership, through this long-term Martian exploration plan that NASA and other agencies are looking at, they're going to go back, send another rover to the surface and pick up these samples, shoot them up into Martian orbit, and then send them back to Earth. Now, these will be the first time that we've ever had pieces of Martian dirt in our hands for us to look at and examine. But there is no way that one organization, one country, one agency can pull this off. This is going to take a multinational organization. And these kind of talks that you mentioned, Daryl, these are the preliminary talks of how this is going to happen. The European Space Agency is already committing to some resources. Obviously, we have Perseverance on the Red Planet committing to this. But this international partnership of us trying to get these samples back is going to lay the groundwork for us to be able to send astronauts to the surface of Mars as well. So these conversations that we're having today are the conversations that are going to lead us to putting humans on Mars in the 2030s. It's extremely exciting. And the fact that these government agencies are coming together now and having these conversations to work out the bureaucracy, that's a really good sign for the future. And that's a really good sign for Martian exploration.
We're speaking with Brendan Byrne, space reporter at WMFE Radio and host of the podcast, Are We There Yet? A reminder, if you have additional questions for Brendan Byrne this evening, please type them in the Q&A portion of our Zoom webinar. He'd love to answer your questions. And I have another question for you, sir. Let's talk in general a bit about space exploration. So it seems that President Biden is a space cadet in the fondest sense of the word. The Washington Post reports that since coming into office, he's installed a moon rock in the Oval Office, watched NASA's Mars Perseverance rover landing on Mars, and backed a pair of the previous president's space initiatives, the Artemis program, which is NASA's effort to return astronauts to the lunar surface, and the Space Force as a sixth branch of the armed services. My question to you is, how unusual is it for an incoming president not to stall or to kill space initiatives backed by previous administrations?
That's a really good question, Daryl, because that's the problem with government-sponsored space exploration, right? These space missions take longer than 4 years or 8 years, which are, your presidential terms, right? So when a president comes in, they usually want it to be their legacy, right? Their, the initiatives that they put in to be the ones that they take credit for. And we saw a little bit of that with the Trump administration when Vice President Mike Pence, who really took over a lot of the space initiatives for the Trump administration. He was the chairman of the National Space Council, which was re-upped under the Trump administration. But they said, we are going to put humans on the moon by 2024. Well, why that date? Because that would have been the end of a second term of Trump. So you're always setting these goals to fit within your presidential administration because that is your legacy. And the fact that we're seeing this kind of crossover with the Biden administration, keeping on the Artemis program, that is very optimistic for space policy folks to see that that they're willing to keep building on this work despite it not being a President Biden project. This is something that Artemis was started in the Trump administration, but Biden's going to go ahead and pick up the torch and carry it through until humans land on the moon once again. And that's really great to see from someone who advocates for space exploration or for someone who wants to see some continuity of policy. You have to look at what the Biden administration is doing and say, this is great. Now, it's obviously not high on their priority list. We don't know who the new NASA administrator will be. They still have a acting administrator. The NASA administrator is appointed by the president and has to go through Senate confirmation. We don't even have names for that yet. But the fact that they are talking about it and that Biden seems to want to go through with this. I heard that he had called the mission control about the Mars Perseverance and said, good job, man, when he called the mission director. So it's great to see that there is this excitement, but more importantly, this continuity over administrations.
Well, that's an important word I wanted to come back to. I don't know the answer to this, so I'm asking for myself. Do our competitors, the Chinas, the Russias, those types of countries who have been involved in space exploration, do they have that kind of continuity in their programs, or do they have those kinds of stops and starts over the course of time?
That's a really good question, Daryl, and I don't know if I cover kind of the international space programs well enough to be able to answer that, but I will say that the goals of the Russian Space Agency have pretty much remained the same. The Chinese Space Agency is very secretive, so we don't know much about what happens until it actually happens. This Mars rover, as an example, the details were very slim until we knew that it actually got into a successful orbit around Mars. So it's really difficult to answer that question when it comes to China. For Russia, I know that a lot of their stuff has continued over. And the European Space Agency generally has kind of a continuous plan for what they do. So I think the U.S. is unique in what you were hinting at in your question. The U.S. is unique in the fact that there are these things. But again, a lot of it does continue over from administration to administration. This commercial crew program, we watched SpaceX launch astronauts. That was started in the Bush days, So, but the Obama administration was the one that really picked up that torch and developed it. So there is continuity. There are some breaks in continuity, but I do think the United States is unique in that sense that is something that we have to worry about.
One thing, even though Biden has shown that he is a supporter of space exploration, one thing still seems unclear. Will the Biden administration preserve the National Space Council, which operates as an office of policy development and handles a portfolio of civil, commercial, national security, and international space policy matters? Have you heard any scuttlebutt about where that's going to land?
I have heard a lot of people that work in the space industry or are actors within the space community would love to see the National Space Council continue. The policy directives that came out of the National Space Council were applauded by the space community at large. Do we know if that's going to continue? Um, we don't. There hasn't been any indication that Biden wants to scrap this program, but there's also really no indication that um, this administration is going to continue it on. We don't know of any meetings that are happening or whatnot. We both know that he's got a lot of other things on his plate right now that are taking priority. Space policy is low on the list of things to worry about in early 2021. But I will say, from talking to both civilian agencies and commercial companies, they would love to see the National Space Council continue because it did give that direction, and it kind of, propelled these issues up the chain of command and put them at the forefront of the presidential administration. So I know a lot of people would hope that it continues. We don't know what's going to happen. It's very unclear, but folks want it to continue.
You kind of touched on this earlier, but I wanted to know, what do you see as the odds that former Florida Senator Bill Nelson becomes the next NASA administrator?
That is also another $1 million question, Daryl. I didn't realize you were going to ask me all these hard questions. Yeah. Former Senator Nelson was very involved in space policy, both in his time as a member of Congress in the House of Representatives, and also as a senator. Daryl, as you probably know, he flew to space. He was a space flight participant and was one of two congressmen to fly aboard the space shuttle. The other one was then Senator. Oh man, I just lost his name. It will come to me, but it was Garn, Jake Garn. That was the Senator Jake Garn, and Bill Nelson. So he's very involved in space policy. Now, President Trump's administration, they nominated a very controversial at the time nominee for the NASA administrator. It was Jim Bridenstine. At the time, he was a House representative from Oklahoma. And Senator Nelson, who had to confirm Bridenstine, made the point very strongly that a politician should not be the head of NASA. It should instead be someone that has scientific or institutional knowledge of the space program, and he criticized Trump for politicizing the head of NASA. Now, fast forward, Jim Bridenstine was a rock star administrator, getting bipartisan support for everything he did. There was even a petition signed by tens of thousands of people to get him to stay on through the Biden administration. But I think when Senator Nelson's name was floated, Senator Nelson was not very open to a lot of the commercialization that the Trump administration was doing when it came to NASA. And those remarks criticizing the pick for Jim Bridenstine could go back and haunt him if Biden were to nominate him now. We are living in a time when it doesn't really matter what a politician says 3 or 4 years ago. But those words could come back to haunt him. And I really do think from the sources that I've talked to, they want someone who is more commercial focused, leaning on people like SpaceX and Blue Origin and all these different commercial companies. And they also, more importantly, they want a woman. They want to see a woman in the position of the head of NASA. And I think that is going to be something very important. That's something that the Biden administration is paying very close attention to, is the optics of having a diverse pick as the head of NASA going into 2021 and beyond.
That's going to be an interesting development to watch. Well, you mentioned I've been asking you some hard questions tonight, and I've saved the hardest for our very last question. And question, yes, and that question is simply, what is your favorite space movie?
Oh, what's my favorite space movie? Oh man, I don't know, because I can't say Star Wars or Star Trek, because you know that is going to really elicit some terrible responses on Twitter after this. I think the one movie, and this is a deep dive into my childhood here. I think the one movie that really made me really enjoy space exploration, and then wanted me to go to space camp as a kid, which ended up helping me get this job, was the terrible straight to VHS movie Space Camp, which I think came out in the early '90s. It was fantastic. I loved it. It was a young Joaquin Phoenix. I think he was like 8 or 9 years old in it. But it was one of my favorite movies. I watched it over and over again. And I wanted to be like those kids who accidentally got sent to space.
Well, that one was not what I was expecting, but hey, to each his own. Well, Brendan, I have enjoyed our conversation, and I really appreciate you gracing us with your presence tonight in this installment of the Beacon Salon Speaker Series. Once again, please tune in to Brendan Byrne's podcast, Are We There Yet? And certainly listen to him as he does his reporting on WMFE radio. That concludes tonight's installment of the Beacon Salon Speaker Series. We thank you for joining us tonight, and we hope that you join us the next time. Thank you very much, and we'll see you. Have a good night. Yep. All right. Can you hear me, Brendan?
I can.